integrated two 911 and 912 combined video. I typically go some by the book, but some not by the book when I do this lesson. So if we were in class, what we would have done is I would have given you graphing calculators and asked you to manipulate this equation. So you can see if it's y equals x squared, it looks like this parabola. And typically what would happen is people would start making changes. Like, what happens if I put a 3 in front? And you can see it got steeper. Well, what if I put a 15 in front? And you can see it got steeper still. So how would I make it flatter? Well, a lot of people think you'd put a negative, but if I put a -6, it just turns the parabola upside down. So it didn't turn it negative, but we did do something interesting by turning it upside down. It turns out that what we can do, when we multiply, if we multiply by a number bigger than 1, it gets bigger. If we multiply by 1, it stays the same. And if we multiply by a number smaller than 1, but larger than 0, like 1/2, it will get flatter. So you'll notice that got a little bit more flat. What if I make it 1/25? You can see it got very flat right there. So that's a couple of things that we can do with this parabola, is we can make it flatter or we can make it steeper. From there, a lot of kids will go ahead and they'll say, all right, well, what if I put like a +3 back here? And you can see what that did is it moved the whole parabola up 3. So if I went -5, it wouldn't be a big shock to see that thing drop 5. And we would play with this for a little bit, and typically that's about as far as we would get in class as far as people making guesses and coming up with something. But I want to draw your attention to the worksheet that I gave you, or I guess I would have given you or made available to you, the one I discussed in the Chapter 9 intro video. This is the form I want you to focus on, the graphing form, y equals a parenthesis x minus h squared plus k. So we had been manipulating the a, and we had been manipulating the k, but we didn't put the parentheses in and manipulate the h. And I do want to point out one thing real quickly that's going to end up happening in a minute that I want you guys to be aware of. If I were to take this thing, I can't write on this like I thought I could, so my mistake, but if I were to put a positive in here, it would say x minus 3. Like if h was +3, it would say x minus 3. But if h was -3, it would be x minus -3. So it would actually turn it into a positive. So ironically, if I plug in a positive for h, I get x minus 3. And if I plug in a negative, I get x plus 3. It's exactly like what happens over here when we get our x-intercepts. So keep that in mind as we go back over to Desmos and look at what happens here. So I'm going to go ahead and block this out, and I'm going to put this in the graphing mode, and you'll see what happens is they give me some sliders here. So I have y equals a, I have a slider for a, and I have it at 1 already, because if I had this at 0, if you multiply by 0, everything's going to turn into 0, and I'm not going to get anything. But if I have this at 1, I guess I should be graphing it. If I have this at 1, you can see that I have a parabola. And again, I'll show you what I mean. If I put this at 0, it's going to go away. And you can see why it's going away is because I'd be multiplying all this by 0, plus I'm adding 0, so it goes away. But you can see what happens as I manipulate my a. If it's very negative, it's very steep and negative. As I get closer to 0, it will become flatter and flatter, but still remain negative. And I want you to see what happens as I get between 0 and -1. You can see it starts to get very flat. I went too quickly there. So it starts to get very flat. When it gets to 0, it turns into a bit of a line. And now it's going to start, again, like we discussed, it's going to get flatter when it's below 0. When we get to 1, it's going to be what's considered normal. And then when we get to above 1, it's going to become steep. So that's one way that we can manipulate that a. Manipulate the parabola is by changing that a. Again, it goes negative, or it goes flat, kind of in between the flat, positive or negative, and then it goes to steep. Now, what if we wanted to move this thing left and right? So I'll leave it 2.4. If I wanted to move it left and right, I would move the h. But again, I want to be real clear on what's happening here. When I move this to -2, it's x minus -2. That's the same as x plus 2. So that goes to -2. Remember I said it's just like getting your x-intercepts out of the factoring form. So If I put a negative 2 in, it's like x plus 2, and x plus 2 moves it to negative 2. If I move it here to 4, you can see as I just slide it along, it's just going to move it left and right. Again, that's x minus h. And finally, the k is going to move it up and down. Right? So if I wanted something at 0.88 that opened down, I would go ahead and move this to 8. I would move this to 8. And I would move this so that it was negative, and then it would open down. And if I wanted it to be steep, I would keep going until I got a large negative number. So that, again, is the graphing form. And that's what one of the things that we need to understand is how does the graphing form affect the parabola. And when we're in the graphing form, one of the nice things is we can immediately get the vertex out of it. When I look, I know it's x minus h, right? So I essentially have a positive 3 in because it's x minus. So I have a positive 3 for my x, and this will be my y. So I can look and see, oh, my vertex must be 3, negative 1. A lot of kids think of it as like the opposite and then the same. Like whatever is the opposite of the parentheses and the same outside the parentheses. However you want to think about it, it's fine. And again, the A is going to tell us if it opens up or down. If it's a positive, it's going to open up, and if it's a negative, it's going to open down. And it's going to let us know if it's normal or if it's steep or if it's flat. And again, that's determined by anything above positive 1 is going to be considered steep. Anything at 1 is going to be considered normal. Anything below 1 is going to be considered flat. Between 0 and 1 is going to be considered flat. And then it's just the reverse for the negative. If it's like a negative 7, it would be opening down, but it would be steep. If it was a negative 1, it would open down, but it would be normal. And if it was a negative half, it would open down and it would be flat. And again, I just want to one more time show you what I mean by that. Let me move these back over to kind of a more normal place. And again, you can see kind of what's going on here. My equation, my vertex is 2, negative 3. So it's 2 because I plugged 2 in for h and negative 3 in for the k. So that's going to be my vertex. And I can easily deduce that. And then my A is going to tell me, again, if it's positive, it's going to open up. If it's a large positive number, it's going to be steep. If it's 1, it's going to open up, but it's going to be considered normal, like just a normal, boring parabola. And if it's between 0 and 1, it's going to be flat, but it will still open up. And now if I go to negative, if I have a large negative number, it's going to open down and be steep. If I have a negative 1, it's going to open down and be considered, like I said, normal. Nothing exciting there, just a boring parabola. And then if I go between 0 and negative 1, it will get flat, but it will still open down. So that is our A, H, and K. That's our graphing form. And that's what we can get when we're graphing form. We can automatically tell the vertex, and if it opens up, down, or if it's flat, or steep, or normal. Now we need to go on to 913 and learn how to complete the square. How do we go from the standard form into this graphing form? That will be our next lesson, changing from here to here.